There we go. Nope, not your internet. Totally my deal. Also, PogChamp. Y'all do anything fun this weekend? Survived. PogChamp, a PogChamp. Drive-in theater, nice. New computers are not supposed to have connection issues. You must be doing something wrong. Wow, Destiny 2. Nice, nice. I did not get much time to play stuff this weekend. I was traveling a little bit and then also doing some woodworking projects on the side. Totally put off mowing my lawn. Nice, nice. Ate a tray of Jello shots and watched live action Scooby-Doo. Carpenter Craig. Both of those are equally funny answers. A beer die table? Is that like a beer pong table? What's my favorite woodworking project? I don't know. I try to learn stuff every time I do any new woodworking, so I'm trying to get really good at like wood glue and clamping and like joints and stuff on this one, like jointing some wood seams together really well, and actually playing around with a different type of stain, like gel stain this time, which is so much better than regular stain. But yeah, although it's pretty much just going to be like a couple of pieces of shelving with carpet on the inside and a little box around the outside for my cat to just jump around on the walls. So, not really the most aspirational project, but she likes to get up on top of stuff. And I'm like, maybe if I make some shelves that she can get up on, she won't be so ready to jump up onto things that she shouldn't be on. But I'm not holding on to that theory too strongly. How is your computer so bad? If you just got a new gaming computer, I don't understand how terrible it is. I actually have ideas to put some bridges in between them with like, but for that I need to like get a sewing machine and some canvas that I can trim down so it's not all like raggedy edged. So version 1 is just going to be 2 shelves that she can jump between, and then I got a really thick like banister post that I'm going to wrap some gnarly looking cord around, and then she can like use that as a scratching / climbing post to get up onto it. The amount of device. Oh, you got like, how many devices do you have on there? And is it all Bluetooth or something? What should I get for dinner tonight? Man, I'm still a fan of BGR and Tadaro's, but I do have Chinese in the fridge, so. Tadaro's is for Wednesday. All right. Fair enough. All right. So, what did you guys think of the previous project? I think that was project 3. I tried to get as much of that stuff graded as possible, but unfortunately, Max, is that a ferret?
Yes.
Do they smell as bad as I've heard they smell?
Yes.
Okay. All right. Glad I stuck with the cat. All right. Carry on.
Project 3 is pretty easy in my opinion.
Nice. I think I got everybody's graded. I tried to send you all messages on Slack for if it was graded. If it was not graded because it wasn't running or you didn't send me an IP address with your thing. So time was printing out weird stuff. Tried like 5 different date things. You pretty much just need to do like res.send new date. So uh a lot of y'all overthought it. A couple people wrote like 10 lines of code, which I found enjoyable to read, but it also worked, so I didn't take any points off. I want to see the ferret. We can switch back to ferret cam after the class period. There's the ferret. Optimal lines of code. Let me look at mine. That was project 3. I had 13 lines of code in mine. Server.js. I mean, since you were just copying the HTML and the thought it was bad to have 10 lines of code. What do you mean you thought it was bad to have 10 lines of code? I have graded all the projects that I could. Rhett, I think I sent you a message on Slack. So go check the Slack stuff. I think I needed an IP address from you or something like that. 19. Yeah. Some of y'all went a little bit overboard with the trying to figure out what the right path was the wrong way. And some of y'all went a little overboard with the time. Oh, wait, I don't have time in mind. So add another 3 lines. So 16. Mine was 16. Ha! This is not the solution one. Apparently, I wrote that and then deleted the stuff before I showed it to you guys. So, but from project 4 on, now I have like my solution project 4 and then like the redacted project that I give you guys. And I'm almost done with project 5. And I also need to take some time and go back and look through the midterm and make sure I've covered everything. So if you guys hadn't seen Slack, midterm is going to be October 7th, that Wednesday. It will be the entire class period. We will not also have a quiz that Wednesday. Surprise, surprise. And it will be all on Canvas. It will be a mixture of some true false, some multiple choice, some short answer, or I guess they call it fill in the blank, but it's not really fill in the blank. No, not open Google. Just do it with what you got in your brain. Can we all get an A? I mean, I suppose if you all try really, really hard. Actually, I think a lot of people, a majority of the class has an A right now, and that's kind of how the grading of all this stuff goes, because like it's a 65-point project and I take off like 10 points for not doing something right and then let you resubmit. So a lot of people end up getting all the projects right. The quizzes don't really count for that much, and a lot of people get that. No, but the midterm and the final are really where it kind of separates out the grades a little bit. So it may be a little difficult. What exactly can we study? I'm going to put together a study guide sometime later on this week, and hopefully on Monday we'll go over the study guide and also go over the quizzes. No answer key. No, there may be some hints towards what to study, and hopefully I've told you all the right answers already, so that's good enough. It is on. Is it on Canvas or with the invasive anti-cheating stuff? It is just on Canvas. I don't really care enough to like troubleshoot 15 people, 20 people trying to run this thing on Linux or Mac or a Windows machine that doesn't run with the right browser, or I don't know. I've just heard terrible things about the lockdown browsers, so gonna try and stay away from that. And there will be one or two essay questions where you actually just write a block of code. So because of that and the short answer, I'm actually going to go through and grade all these things myself to make sure they look right. So I'm not going to rely on Canvas auto grading it like I do for the quizzes. So it might take me a little bit longer, but I hope to have all that done by like Friday or Saturday and get it all back to you. And hopefully a little bit after that, we can go over the results. Speaking of going over things, we got this here project 4 now available to us. So today I would like to go over how forms work at least a little bit, and I'd like to go over I'm not sure how much I included in the starter package, but I'll go over some of that, and we'll go over what all is different with project 4. We've already talked a little bit about some of that stuff, like I think I said last class. Project 4 would use npm start instead of just calling node directly from the service file. So we'll be actually putting slightly different stuff into our package.json. I think I wrote some of that stuff down here. I didn't. Okay, well, I'll go write some of that code up. I'll make sure that that's in here. But this is pretty much the setups just like project 3. So I guess I'll go over this real quick. We'll have the same document root and server folder, and then inside the server folder we'll also have a DB folder for our database. Our database in this version is just a JSON file. Next project, our database will actually be a Redis server running on the same box, but for now this is what we get. Since we do have a document root that's serving up static files, we do need to symlink that into var www.html project 4. I did actually get my own domain name on AWS now. So I have craigbaker.io. Fancy. And so there is a starter file there. It cost, I think, $35 for a year of the domain. And then I get all the SSL certs for free. And then I had to set up an S3 bucket, and then to get a HTTPS on front of it, I had to actually set up some CloudFront stuff as well. So it's probably going to cost some money. No, I'm not going to get reimbursed for this because this is I want to keep it. This isn't the university's domain name. This is my domain name. I'll probably put other stuff on here like a homepage and my resume and stuff like that eventually, but it's just nice to have a S3 bucket that I can upload stuff to, and it just comes out as CPSC 3750. So that's nice. Okay, so we do have a new location block in our Nginx file. It's just project 4 dynamic instead of project 3, and we changed the port number here to 3001. Make sure you restart Nginx. Make a new service file, and here this is the difference in the service file. So in the last one we were calling node start. In this one we're calling in the last one we were calling node server.js from a specific directory. And in this one, we're calling npm start, and we just tell it what directory we want it to look in the package.json part. So in the next project, we can just copy all this and just change this 4 to a 5, and all of this will stay the same, which is pretty sweet. Package.json actually has stuff in it that tells it what port to use and stuff like that. So let me go over here. Clear. Okay, well, it reset my. Okay. Did it die? Oh. Well, that's not great. Hmm. Okay. Well, I'll talk a little bit about that later. Um, seriously, what the hell did I do to kill my instance? Now I got to log into AWS. Did it just like restart and give me a new IP address? Because that wouldn't be cool. Let's see. Okay, let's pull this over to the browser. There we go. F. So I have a running instance. It says it's running. 227.6570. What are we doing wrong here? Hey, it's failing health checks, status checks. Instance recheckability failed. Well, I guess I'll just restart it. Yeah. I'm wondering if it's because I did some I just installed or compiled and installed Redis, because for Project 5, we don't install Redis from a package. We actually get it from the source code repository and do like make install and all that stuff. So I wonder if that has something to do with it, but it worked after that, so hell if I know. Let's see. Did it actually reboot? Let's see if I can do a session manager. Yeah. Well, SSM isn't installed on there. That makes sense. Okay, now I'm in. Cool. Project 4, server, and package.json. So we actually moved the environment variables and the proxy path into the start. So when we call npm start, it'll set these two environment variables for us, which previously we were just hard coding the port in our code. Now we're actually pulling it off of process.env. And let me see if I have that code. Project 4 redacted. Okay. Sublime. There we go. So here you actually see I'm using process.env.node port and saving that into port, and same for proxy path like this. And so at the very bottom, you can see here that we're just using port, which is the variable that we assigned up top. And is all this? Yeah, okay. So this is one of the places that we're going to, this is kind of the scheme that we're going to use to when we need to use the proxy path. So I need to talk a little bit about forms, but generally speaking, when you click the submit button on a form and you haven't overrode it to do like an Ajax submission, but it's just like the regular what a browser thinks it needs to do, it creates a body or an HTTP packet and sends it to wherever it's either a post or a get, whichever you define in your form. So if we go look at index.html, this action here says this is where I want you to send it. So right now we're in the, where are we? We're in the registration folder. So we'll be in document root registration index.html. So this is going to be in the URL project 4/registration. So we have to go up a level to get to project 4, and then we have to go over to dynamic, and then we have to go to user. So this is the action. This is where I want it to send it. This is the posts, or this is the method. So it can be a post or a get. And then it's actually going to use all the stuff in this form, and it's going to use these names. So here's an input. So I have a nice label around it, and then I have this input, which is not drag and drop. Okay, all right, come on, there we go. So then we have this input here. It's named user ID, but all the stuff on the front end is username. So this is kind of just, I intentionally did this a little confusing. We can call it username on the front end, but when it talks to the backend server, it's going to send the data across in a key called user ID. Password is actually just called password, type password, ID, password, name, password. So this one will stay the same. But for this one, when you receive stuff in Node.js, you need to look in the variable user ID. And when you send stuff back to the user, you need to say, hey, your username is not good, right? Just to make sure you guys understand that these two things, the ID and the little label and stuff like that, these things don't have to match the name. The name is what the form uses when it's making key value pairs to send to the server. So one other thing to note here, and I think I might actually put this on the midterm or on a quiz this week. This is type text. So when I type into it, I can see what I'm writing. This is type password. When I type into that, I just see stars. Don't use type text on both of them. I will take points off. I think you have to write your own. Okay, well, that's the wrong one. Where's my redacted one? Yeah, okay. So for Project 4 redacted, you have to write your own form to log in. You have this registration form as an example. Please follow kind of my examples here. Don't do type text for a password input. Don't do it. It's stupid. It's dumb. Don't do that. And then also at the bottom here, I have confirm password, but we don't need to send the confirm password. So this is where like type in your name, type in your username. So we have, username or user ID if you're looking at it on the server. Then we have name, and that is like what, Craig Baker or whatever, right? Then we have your password, and then we have this little strength meter for your password. And then we have this confirm password. We don't send confirm password to the server because the server doesn't need to confirm that you typed your password twice. That's just a little helper thing for the user, right? There's certain things that you always want to also validate on the server side and the client side. The reason you validate it on the server side is it's the only way to be sure, right? Nuke it for more, but it's the only way to be sure. But the reason you validate it on the client side is so that the user knows before they click submit, or when they click submit, it doesn't actually submit kind of thing. So client-side validation is like a polite thing that you should do when you're writing things that take input from the user. Like, don't try and send it to the server without validating it, because if you send it to the server and it comes back with an error, then a lot of times the form's completely blanked out. And I'm sure all of y'all have been at some crap website where you type in like 15 fields, including your credit card number and shit like that. And then it's like, nope, I'm sorry, your password didn't have an exclamation mark. Start all over. Right? And the 3 wacky digits, the CCV code. Yeah. So, and then you type all that stuff in and you click submit, and it doesn't do any client-side validation. It sends it all to the server. The server sends back an error code, and the page reloads with nothing in it. That's crap code. And the easiest way to prevent that, I mean, you can like store all that stuff in a cookie or something client-side on the browser. And if you end up back on that page again, you just fill out the form with the stuff that was stored in the browser. But like, the easiest way to not do that is to just not ever send the form to the server. So this one, we're validating a bunch of stuff client side, and we're validating slightly different stuff. Namely, we're not on the server even sending the confirm password. All we're doing is being like, this is a nice to have. This is not a requirement. This is not going to break our application if you have not confirmed your password. If you're trying to hack our system, you don't need to send the same password twice. Like, if you're using the UI correctly, then you have typed your confirm password and it is matched. If you're not using the UI correctly, I don't care, right? Then you've set a weird password that you don't know. Congratulations. So that's why this one doesn't have a name on it. And that's how we tell it not to send it. This name thing here, there is no name attribute on the confirm password. So this form is not going to send it. All of these things are inside this form, including the submit button. Type equals submit. When I mash this button, it will gather up all of the data that has names on it, right? So these 3, that input, this input and this input, it will make a set of key value pairs. So it'll have user ID and then the value that's in this one. It'll have name and then the value that's in this one. And it'll have password and then the value that's in this one. And it'll gather it up into the body of a post request because we're posting, right? So if we were doing a GET, no, on the client, you do need to check that the two passwords match because that's part of the requirements. That's also something nice to do for the user. But we are not sending that field to the server, so there's no way for the server to check that those match, right? So because we're posting, all of these things get packaged up into the post body of an HTTP request. Remember, that's after, you have your first line, you have your post, and then you don't, it's not going to actually put dynamic in there. It's going to build out the actual thing. So it'll be project /dynamic. It's not going to do the /user, HTTP 1.1. And then it's going to have host, blah, header, to, blah, all these headers, right? And then it's going to have an empty line. And then it's going to say user ID equals Craig B, ampersand, name equals Craig, ampersand, password equals whatever my password is, right? This is what the packet's going to look like. If instead this method were a GET, it's going to send the stuff differently. It's going to take all this stuff. So let's just, password leak. You're right. I should have chose a stronger password, like password 1, right? So if I do a GET, it's going to send a GET request, right? That makes sense. But it's also going to take all of this stuff and throw it into this line, which means it's also going to be on your URL bar and in your browser history and all of that stuff. We're doing a post because we don't want your password to be in the browser history, right? Everything after this question mark, it's going to be stored in your history. It's going to be visible across the internet. It's just very insecure to use a GET request to send stuff like that. You could use, if, for example, our form was like Google search, right? Then that would make more sense because it's just Q equals like bees, right? And like, okay, but without the quotes, right? So this is the query, right? And nobody really, it's fine to send that as a GET request because yes, that's what you search for. And in fact, you probably do want to go back in your history and find the last time you made this cool search that you actually got some cool results on, or at least that was the idea back in the day. Now you can just ask Google for all the stuff you searched for and you don't need to look through your browser history, but you could also use this to like spy on your kids and whatever they're looking at, so there are use cases for both. You probably don't want to do like a Google style query as a post, and you probably don't want to do a registration as a GET, right? So you have this whole thing and you click this submit button. And if we go down, and I guess I can at least show you kind of, let's see, service project. Let me make sure my project 4 is running. Please, okay, that failed. Let's do stop and then start and then status. All right, that's green. Okay, so now if we go over to the browser, go look at my project 4 directory. I think I've shown you guys. Yeah, I know. You don't need to see me stopping and starting stuff that should have been working already. Okay, so registration. Here's kind of how I want it to look. This actually is a form, but on top of that, as I type stuff into it, Why is it not working? Did I cut that code out? I feel like I cut that code out. All right, well, this should be sending off GET requests. Let's see, why is it not? All right, let me go. I'll show you my terminal. Where are we? There we are. I think I uploaded the redacted version. I don't know why I would do that. So let's put the real version back in here and see if that works. And let's also put the document root stuff in there. Oh, I know why. Because I actually wanted to test installing stuff. I wanted to test to make sure that the tar file that I gave you guys and the instructions for unpacking it work right. So I actually unpacked it on my system. That's why. So upload all the stuff that actually should work. And then stop and start my project since I changed the file, and then reload this. ADMIN. I'm getting an XHR error. Well, would you look at that? What did I do wrong here? Bad gateway. Oh. Well, why? It failed. Okay. Stop. Status. Still failed. Stop it again. All right. PS-EF pipe grep node. Let's just go kill some stuff. Node port 3002. Why is it 3002? Shouldn't it be 3001? Lib. So yeah, debugging. System D. Terminals blocking. You can't see the terminal and then the terminal's blocking. Okay. Strikes to fear in the heart of every part. Yeah, it does. System. Project 4. Okay. Cat package. This should be 3001. It is 3001. And this is project 4 server. Okay, sudo service project 5 server stop. Let's do that. Then, okay, so project 3 is running, but okay, maybe that was it. Let's try rerunning project 4. Hey, it's happy. All right, let's go back to the browser. Reload this thing. AD, nope. Okay. It crashes. Why does it crash? Okay. There might be something that I need to update in the code. We don't need to worry about that right now, because if I show you guys how to fix it, you're just going to see tons of code. I'm wondering if it's because, I don't know. I'll look into it later, and if I need to update the project stuff, I'll let you guys know. But it should be returning a exists true or exists false, and I think I have that in. So if we look back to Sublime, we should debug it. Yeah. Let me see if I can figure out where, depending on how hard it, depending on what I have to show you guys to debug it. Nope, not that one. Give me a second. Let me look. You know what? Let's just do npm. Okay. Let's just see what the, okay, that's the wrong one. Thanks. npm start. Let's just run it in the foreground. This is, remember, it's hard to get those logs. Okay, so it's still running. Stop that. Status. Okay. npm start. And can't find module express. Oh my god, because of course that's why. Okay. Is that even going to have anything in it? Or everything in it? Body parser, express session. Let me, did I add anything else to this one, or is that the right one? Express session, body parser. Okay, so that actually is right. So npm start. Oh my god, now it works. All right. Back to the browser. Yeah, remember to npm install express. No, because my package already had all the dependencies, body parser, express, and express session. So this, you're right, that was a question last week. npm install just installs everything because it found all the right stuff in package.json. Okay. Now, M-I-N, there. Thank God. All right, so now we get a thumbs down, which is what we're looking for. So, you know, I can type into all these fields and I can click submit, and the form will actually send all this stuff to the server normally. But if I go back to this code, if we look in, and I believe this is the redacted index.js for registration. So up here we have all these error messages. I wrote these out for you because I want you to use the same error messages on the client side and on the server side. This also, I also want you to use the exact same error messages on the server side because I'm using Postman to test that I get these exact error messages back. So make sure you use these error messages, especially on the server. Don't really care so much on the client. But we look down here at init, and I'm actually doing all this stuff for you. So we actually have 3 different top level callbacks, right? We have this form node, which is just get the thing that's ID form and attach the on submit callback. Makes sense. The on submit callback, it just it basically runs all the validation, and if it passes validation, tells the form that it's okay to submit. Otherwise, it is not okay to submit. So if we go look at on submit, we just run the validate function here. We call e prevent default. E is the event, so we're preventing the default action of the event, and then we're returning false. And otherwise, we return true, and the form continues to submit to the server. Validate function, you guys get to write that yourself, but I left you a ton of comments for how to do it. Set username status, no, I'll not talk about that just yet. Okay, so on username change gets attached to the username field, appropriately named. It runs both when you lift up on a key and when you paste into it, so that you don't actually, otherwise you can copy paste into a form and it won't actually run the validation or update or anything. If you ever use password managers and you're on a crap website that's like, you have to use all these things to make me happy, and then you paste something in from your password manager, it's like, I haven't updated that you have to use all these things to make you happy. That's because they don't have an unpaste handler. So we can run the same function twice. It does generate a few more. It could at some point generate a few more, like if you control V, that counts as a key up and as a paste. But if you right click paste, then that just counts as a paste. So in some cases, it will send 2 different queries to the backend server, By the way, what this function does or should do is it uses Axios to send a XHR request to the server. So whereas forms, all right, let me take a step back. Go back to the form. I left off a piece here. Okay. I said that it sends all this stuff to the server, right? And that all makes total sense, but it doesn't stay on the page that it's on. It sends all the stuff to the server, and then whatever HTML or 302 redirect or whatever the server sends back, it loads that as the new page in the browser, okay? So when we click submit here in the browser, let's go over here. And if I do admin 2 and Adam, and by the way, the easiest way to pass this with the minimum weakness that I want you to is ASDF space, ASDF with no second space, because we're using a password strength checker that looks for duplications. It looks for things that are next to each other. It looks for like consecutive strings. And it also does dictionary lookups and all that stuff. So this is really like, if you guys ever read like the battery horse staple or whatever XKCD thing, horse battery staple, password strength. If you guys have ever read this, like, this is actually easier to guess than this, because this is 4 random common words, but this is a hell of a lot harder for humans to remember and easier for computers to guess than this, which is actually pretty easy to remember. So this password thing that we're using, it's called ZXCVBN, which if you look at your keyboard, unless you have a really weird keyboard, should be the bottom left row of your keyboard. They made this, it was made by Dropbox, or like on the side open source by Dropbox. They made it because nothing else really takes into account like, oh, let me just hit all of the, what about dictionary attacks? Yes, but that's what this 4 random words takes into account. It's like, okay, if you're doing a dictionary attack and all of my words are at least 5 letters long, then the amount of dictionary items you have to look through is actually greater than trying to find one dictionary word and replace some of the base words with numbers and stuff like that. Of course, the strongest thing is to just use a password manager that's a completely random 28 character string with all kinds of like numbers, letters, symbols, and all that stuff. And that's what you should all be doing. And you should all have a different password for every website, so that if one password leaks your website, you don't have to go reset it everywhere else. But if you aren't using one password for every website that's completely random from a password generator, so you don't have to worry about remembering it, then 4 words is actually way better entropy, right? Because you're just like, each of these is, I forget how he gets that, but each of these blocks is a bit. So it's 4, 8, 11. So it's like, if you had to, the entire range of things that are at least 5 word or 5 letters in a dictionary. I use KeyPass. It's open source. It creates an encrypted database that you just throw up onto Google Drive or wherever you want to store it. You can pull it down from anywhere. It's got an Android application. It's got Windows, Mac, Apple, Windows, Linux, Apple, desktop things. I don't integrate it with my browser, so I actually go over to it, double click it, and go back to what I'm doing. Bitwarden's also good. I don't like my stuff. I don't know about Bitwarden Act too much, but I just don't like my stuff being stored in a cloud where somebody else can get the encryption keys. Yes, mine's stored in the cloud, but it's encrypted with my master password. So it's not really that, it's just random data to them. And there's something else good about it, but I can't remember. My master password is not ASDF. Okay, so password generators, yay. So that's why we're using this password checker, right? It's to make sure that somebody has at least a fair password. So one of the requirements is like, you call this library, you run the password through it, you make sure that it's at least strength 3 or better. And you also call my function that I give you that says this is a fair password and sets the color and the strength of this meter. You don't have to write that HTML. I already got that done. You just figure out what the strength is and you call my function. And if it's less than 3, then you also fail the validation. Easy enough, right? So I fill all this stuff out and let's see, I'll clear this and I'll click submit. Notice it sent a post to this thing and my server sent back. Okay, go over here, 302 redirect. Hey, my value is not defined. Huh. I guess I have an error in my code still. Okay. This is what I get for coding it on a weekend while drinking. Don't do that. Right. So we get a 302 response back. And that 302 contains a location header, which Balmer's Curve, Balmer's Peak. Yep. I think I've been into Scotch a little bit this weekend, but or last weekend. But so project 4 login is where it sends me, right? So it sends a 302 redirect. When a browser sees a 302 status code, it looks for a special header called location with a capital L. And this location is project 4/login. And then I put some extra stuff in the hash mark. Remember, the things after the hash mark are never sent to a server, but the server can still send it to the browser, right? So it's a cool way for the server to send back messages to the browser. So this message, registration successful, please log in. It's URI encoded, and it's what gets displayed right here. And if we go back 1 second to, so this is how forms work. You don't just submit a form and then stay where you are. You submit a form and you either get redirected back to the form you were on with a message that's like, hey, that was dumb, go do it again. Or you get sent to the next place, like, okay, that worked, go log in now. Or after you log in, it should send you to like, oh, you're logged in, go check out this user info page to make sure that your name is right? So that's how form redirection, or that's how we want forms to work. A lot of times, especially in PHP, things will just submit to themselves, which is just crazy. You're just like, the code is like, if I don't have a user ID or a password variable, then this must be the first time the user is seeing the page. So I'm going to render it blank. If instead I've been hit, the browser has sent me, has hit my page with those variables, then I get to do something else and redirect them to a new place. So we're kind of not even going down that rabbit hole. It gets pretty confusing. We're actually having things post to somewhere like dynamic user, and then dynamic user either sends you back where you came from or to the next step in the process. And they aren't named, nothing's named the same, right? And if we go look at the server that I gave you, the server thing that I gave you, here is an example of how to do one of those redirects. And here's where we're using the proxy path, right? Because if you guys remember, the proxy path variable that we set up in here is /project4. That's because we want this code, so that proxy path is just the string /project4. And it is that way because we want this code to also be able to run in project 5 or project 6 or wherever we put it. So we abstract that variable out into an environment variable, and then we can just drop it in the beginning of the string. Remember, we're using backticks here, so this is a templated string. So it's going to start with /project4, which is a contents of this variable, and then it's going to have /login, and then it's going to have a £, and then it's going to have an encode URI component of whatever error message we want to display. Now, error messages in this case is kind of a misnomer, because some error messages might be login success, right? So, sometimes it's not an error message, but it's just all in the error message array anyway. But this is how you actually convert the things that have like the error messages up at the top. They have spaces in them. The stuff after the £, should not have spaces in it. It should be URI encoded, not URI component encoded. So because this is a part of a URI, we need to encode it as part of a URI. So this is how we should do all of our redirection, right? Even so, this one is, you are trying to hit user info, and I actually gave you this whole function. You're trying to hit user info, If you don't have a session, or if your session exists but you don't have a user ID in it, then send them to login. Otherwise, pull out the user ID out of the session, call get user, which talks to our database JSON file, right? Put the user ID into it and then get the name out of that. So this will return an object. That object should have a name, a user ID, and don't put the password in there. Do not put the password in there. We're not putting passwords into our database because that's how people, that's what happens when a database gets hacked and all of a sudden all of your username, that one username that you use everywhere, and that one password that you use everywhere because you don't have a password manager, and that's just stored plain text in a database somewhere. So as soon as somebody gets elevated privileges to talk to the database, now your one username and password is visible to everybody. They don't have to do any extra work to decode this stuff out of the database, right? They just have your password. We're not going to do that. We're going to be super secure. We're not even just going to like hash it. We're going to hash it and salt it. All right. So I will get to that in a second, and I'm going to talk all the way up to 5:15 today. Don't worry. So you get your name out, and then you do res.send, and I use a template variable again, and I'm just building out this really simple HTML body, right? And I'm putting these template variables into it. So that is what happens when you log in. And if I go over to the browser, I've already registered this user. So if I can remember what I registered it as, actually, let's go over here. Request payload. See that? It has my stuff right in there. Admin3, username, name is that, password is that. And it actually changed out my spaces for pluses. That's fine, because the server side knows how to decode that stuff. So ASDF, enter. Don't save. User not found. User not found. Did I do that right? Okay. Yep. It no work. But, oh, there should be a hard-coded. So that's one thing I also put in here to make it easier to test, is there is a hard-coded user. So if we go back here, at the very top, I create this hard-coded user, and it's got the 4 things that I talked about in here. So it's got a username, it's got a name. The salt is stored in the database. The salt is different for every single thing we use in the database. So like every user has its own salt. Every user also has its own password, but we don't store that in here. And the way we compute this password hash, so this salt right here, it's just the timestamp, right? The cool thing about like a SHA-256 process, which hopefully I'll be able to show a video on if we get through enough stuff about how complicated that is, but like you change one bit of the input string and it generates a completely different output string. And it's very, very, like there is no mathematical way that we found so far to reverse something that comes out of a SHA hashing algorithm back to what you put into it. So the only way that you can actually get this right is you kind of have to try everything, and it'll take forever to try everything. Now, if we didn't use a salt, there's something called a rainbow table. And a rainbow table is where somebody has just pre-computed every single string up to a certain length and what its hash value is. And then just there's a terabyte file out there that is like, here's the SHA-256 hash of every single string up to this length, right? Cool. You could do that. That's fine. But and a lot of times it's for not every single string, but once you get past like 3 or 4 strings, they just have to do like combinations of dictionary words or something like that. So if you actually get a hit in your rainbow table, you have this password hash, you have this like SHA-256, right? Yes, Zach, the salt changes things because this is the output. And if this matches, so let's say you used a password of Go Tigers, right? Because who would ever do that? I'm sure none of y'all have anything like that in any of your passwords. Actually, no. The way I wrote the password checker, it should not allow tigers anywhere in there. Okay, so I mean the one for Clemson, by the way. So this is the output. If I were to write Go Tigers as my password and it generated this password hash, Go Tigers would probably be in a rainbow table somewhere. So if somebody got access to that database and got the salt, they could just plug, or got this password hash, they could just plug that into the rainbow table and out comes Go Tigers. And then you can say, okay, this username or this email address has the password Go Tigers. Awesome. Now we can publish that and make everybody feel bad. But if we salt it, we now have, we're not just putting into our SHA function the password. We're taking the password and a unique string at the end of it. For me, it's a timestamp. So the current timestamp of when the user was created. It's going to be different for every user. So it's never going to just be a single word. It's going to be, even if you chose a shitty password, which we're not really supposed to be allowing, but even if you chose an easily crackable password, then the salt makes it so that it changes the entire output, right? So if you want to check, and so we're not storing the password, well, how do we know that somebody has given us the right password when they try to log in, right? Well, we have the password hash. We take the password that they gave us to log in. So we already created a password hash, they registered, we stored the salt, all that stuff. They try and log in. We take their username, look up this user object out of the database. This user object has the salt that was used to create this password hash. We take the password that they just gave us, use the username to find the salt, add those two together, and then create a new hash. And if that new hash matches the password hash in the database, then they've given us the right password. It's a little bit complicated, but that's because it's secure. Nothing secure is easy, right? So that's how authentication is going to work. That's how we make sure that we never, even I, as the runner of this database, unless I put in like a console log somewhere to also write the unencrypted password out, I don't ever see your password. This doesn't work for all systems. Clemson actually does not store password hashes. They store encrypted passwords. The reason they store salt can be kind of whatever you want as long as it's unique. So I think in Project 5, instead of a timestamp, I use the actual huge long ISO string just because it gives me more entropy. It's just a longer thing, which means that the password that generated, the actual string that generated the hash is that much longer, which means it's even harder to find in a rainbow table. But Clemson does not hash their passwords. They encrypt their passwords, and those passwords are decryptable. I did say, yeah, the salt for each user gets stored. So when you do registration, let's see if I actually gave you that code. No, user, post user. All right. So this actually tells you kind of what you need to be doing. So generate a salt using the current timestamp, generate a password hash using the salt and the password. Create a user object containing the user ID, name, the salt that you just made, and the password hash you just made. And you store all of that in the database. And you do not store in capital letters the password in the user object, because everything that goes into the user object, eventually the user object gets passed into save user. And this just stores it into the JSON thing, which means like it's just a file on the disk that anybody can go look at, so you don't want passwords in there. Going back to Clemson, the reason they don't hash their passwords, which is the best thing to do, is because they also need to set your passwords up in other systems. So they have to be able to decrypt your password so that they can tell G.Clemson what your password is. A lot of things actually have started to become integrated with the gray and orange login page, which is completely under the control of Clemson. So anything that uses that, actually, they don't get your password. They ask Clemson to authenticate you. Clemson authenticates you and then sends you back over to whatever you're trying to talk to at like Canvas. And Canvas is like, cool, Clemson said you're good and your name's Bob and you are a teacher of this course or whatever. So Canvas doesn't get your passwords at all. Other things do. Like I think G.Clemson's a good example. There's a couple other examples out there that we aren't actually SSO enabled with, but I say we as in I still work for them, but I don't at the moment, except for in this capacity, obviously. Okay. So this is the compute hash function. It takes in a password and a salt, and it returns the password hash. It does a SHA-256 hash, and up at the top, we already are requiring the crypto library. If you Google how to do it, there will be two initial hits. One is using the built-in Node.js crypto library. One is using a library called SHA-256, which just does the same thing, but you have to install more packages. Please use the crypto library. This is literally going to be a single line of code. It's going to be a line of code with like blah dot blah dot call this thing dot add this thing to it dot and then return the whole thing. But this is all one line of code. You'll find it in the Node.js example, like the core docs for Node.js for the crypto library. I feel like I've been on so many tangents, I don't even know where I'm at anymore. It's 5:02. Anybody need me to go back over anything I've talked about so far? Anybody? How to check the password. Yep. So okay, so that's in login auth. Yeah. So you have saved after they've been registered. Their object should exist. So the first thing you do is like, okay, well, you have given me at login page, you've given me a username and a password or a user ID on the back end, right? Like everything in this code is going to be like rec.body.user ID or whatever. Yeah. So this is where we're pulling the user ID and the password out, right? This is some fancier JavaScript than we've done before, but it does the same thing. So we get the user ID and the password out of the body, right? We make sure that the user ID is not blank or empty or anything like that. And if it is, we send them back to the login page with an error, no user. Then we do the same thing, which I ripped out, for the password, right? So we'll also check that the user password exists and it's not empty. Then we'll try to find that user in the database. So we'll do a get user and pass in the user ID that they gave us. That'll either return false or it'll return an object. If it returns false, there's an error message for that. Do the same res redirect, this whole encode URI thing, send them back to the login page and be like, user not found, which coincidentally is the error message I was getting when I tried to log in with the user I just created a little bit ago. If you found the user object, then you have a hold of the salt and the password hash, and you have the password that the user just gave you. So you take the user, the password that the user just gave you, and you take the salt that came out of the user object for that username, and you pass them both into the create hash function, which is that one-liner that you guys have to write, takes in a password and a salt, and this will give you a hashed password, like an actual SHA-256 hash out the other end. So you call this thing, you put in the password that they just gave you, the salt corresponding to that user ID that's stored in the database, and you get a new hash. And you compare that hash to the hash that's in the database. So in the user object, there's a salt and a password hash. Use the salt plus the password they gave you and compare it to the password hash that's in there. Does that make sense? Okay, cool. So I didn't get to talk too much about XHR today, but XHR is different. That's the thumbs up, thumbs down. It's also called Ajax. By the way, both of those namings are wrong, but that's what most people call them. XHR stands for XML HTTP request. Ajax stands for asynchronous JavaScript and XML. Nobody uses XML anymore when they're talking to the server, right? So, but it was all named that because JSON didn't exist at the time. Ugh, got something stuck in my throat. Okay, so the difference between either of those things, they both mean the same thing. And a form is a form actually sends something to the server, gets an HTTP response from the server, and reloads the page with that HTTP response. That response can actually be HTML, or it can be a redirect to another page that's HTML. Okay. Ajax doesn't reload the page. Ajax is just JavaScript sending a request to the server in the background, getting a response back, and then doing something with that response. For us, we're changing the thumbs up to a thumbs down or back and forth. And if we go, I wonder if I have that code written for you guys. This is the thing that sets the username status, so you would just call this with whether it exists or not. And this is the on username change, and I completely ripped it out. So we do have at the bottom of our index, I want you to use this library. Nope, this library, Axios. Axios is way, way easier than having to deal with using the built-in browser functions. And then you have to check on the status of the request and all this stuff. Axios just gives you a promise back. And so you're like, hey, Axios, send off this request. Then, whenever it comes back, run this code. So much easier. So we're going to use Axios. Talk more about that on Wednesday. I don't have anything else to talk about today. If you got any questions, ask them now. Otherwise, peace out. I'll see you on Wednesday. What is Wednesday's quiz going to be on? Ajax and form stuff, I think. I'll make sure, I'm going to read over the quiz again this afternoon. I'm going to make sure that by Wednesday I know exactly what's on the quiz. I have that refresher, and I'll make sure I teach anything that I've missed so far today on that. No problem. All right. Any more questions? Send me on Slack. I'm out.